Greetings everyone, and welcome to the launch of Chang'e 5 from Wenchang Satellite Launch Center in Hainan Island, southern China. So this launch, we actually have live coverage of it. We don't normally get Chinese launches, but this is a big deal for them. This is their lunar sample return mission. A little background I wanted to cover on the mission. So this is the fifth Chang'e mission. The previous one, Chang'e 4, landed on the far side of the moon. I'll say the far side of the moon, not the dark side of the moon, although it is dark half the time, like our own planet. Here we go. Wenchang Satellite Launch Center is located in southern China on this large island called Hainan. And it's China's newest launch center. It only opened a few years ago. And this is only the Chang'e 5 mission is only the second production Long March 5 launch. The first one was Tianwen-1 back in July, which was their Mars mission. So Long March 5 is a big fella. I'm not sure how forthcoming they are with the deets, the specs. All right, so Long March 5, 57 meters high. That's 187 feet. 5 meters, 16 feet in diameter. Two-stage rocket. As you can see, it's a central core surrounded by, looks like 4 boosters. The let's see, the boosters are they use RP1 and LOX, just like the Falcon 9 and Falcon Heavy and Saturn V. And the first stage uses liquid hydrogen and LOX, just like the Delta IV Heavy. Second stage also uses liquid hydrogen, and then the third stage, which is optional, uses hypergolic fuels, dinitrogen tetroxide, and UDMH, the unsymmetrical dimethylhydrazine. So standard fuels, nothing unusual. Okay, so first CZ5 launched from Wenchang spacecraft launch site on 3 November 2016. Did not reach its intended orbit, but it was a workable orbit. A second launch in 2017 failed due to an engine problem. And then after that incident, the Chang'e 5 mission was delayed by, I think, a year. I think it was supposed to launch last year. But so the profile for the mission is after they launch, they're going to cruise over to the moon. There are 4 main components of the mission. There's the orbiter, the lander, the descender, and the re-entry capsule. So the orbiter and the re-entry capsule are going to continue orbiting the moon, while the lander with the descender attached are going to go down to the lunar surface. They have a core driller that's going to take a core sample up to, I think, 2 meters deep, which is pretty deep. And then the descender, I guess, is the ascent module, I guess you could say, is going to rejoin the orbiter in orbit around the moon, and then return to Earth and descend back through the atmosphere in the re-entry capsule. There. So, no audio, it's all in Chinese, but yeah, there you go. Joe Blow, thank you very much for that. $10 donation, coffee and donuts. I do have my coffee right here. I made it just before starting the stream. That's why I was a minute late. Mike Clam says, wow, a 2-meter drill. I hope it works better than InSight landers. That's, yes, hopefully so. Now, the lunar surface, the lunar regolith, is very different than the Martian surface, although, well, there are similarities. The Martian surface is covered by fine powder, and as is the moon's surface, that's pulverized, rock deposited from thousands upon thousands of impacts. All right, let me scroll up the chat and see if there are any questions pending. MVM Motovlog Music asks, has yesterday's Starlink been rescheduled? Yes, that is rescheduled for this evening, about, 25-ish minutes earlier than it was scheduled for last night. If you look at here, I'm going to link my calendar in the chat. Go ahead and click that link to go to the Raw Space calendar, which is also linked in the video description, so that you can keep up to date on the launches, the live streams and other events coming up. I usually keep it accurate within about a week. Much past that, and there's almost no point in putting things on the radar beyond that unless they're important missions like crew launches or things like that, which don't usually get moved around too much. But, satellite launches and Starlink launches and things like that, they get shuffled around all the time. So unless you're within a few days, chances are, the date is going to be fluid. Toon van der Pas, this is the Long March 5, isn't it? Cool. Yes, it is. This is the Long March 5. And I guess I was incorrect in saying it was the second production launch. So, let me see, launches. So, yeah, 2016, 2017 was a failure. 2019 was a success. And then, in May of this year, and then in July, which was the Tianwen-1. So I was missing a few launches. That was my bad. Maria Kutujan asks, how long will the mission last until the return with the lunar samples? I'm not sure of the timeline of the mission. Or if there's no rover, it's just a lander and a drill. It probably it's not like they have to wait for alignment of the moon and the Earth, like, with Mars. I mean, the moon is right here. It's circling us every 28 some odd days. So there's no particular reason why they would need to have an extended mission unless they were going to... I mean, the orbiter is going to continue to orbit until... Well, yes. So the lander comes down, the lander goes back up, the lander rendezvous with the orbiter, and then the orbiter returns. And the orbiter will burn up, the descent module will then, descend and splash down. But Microsound feels sorry for me because I will tangle my tongue. Yes, that's likely. Chang'e 5. If that's close to correct. Ian Pedlar, if the moon is that close as in the picture, it should take 5 minutes to get there. Yeah, I did a little photoshopping to the thumbnail for the stream, and put the moon there behind the clouds for dramatic effect. Obviously, the moon is not that close. If it were, we would have some crazy big tides. Sinway Jimenez asks, should the moon be mined? Well, I think the moon is largely made of the same material that the Earth is made of. After all, the moon is sort of made from the Earth. as the result of a impact in the early solar system with a Mars-sized body, which formed the Earth and separated to form the Earth and the Moon. But potentially helium-3. I'm not sure if that's valuable enough to warrant the expense of mining on the moon, but it sure worked in the movie Moon, which was pretty cool. 2007, if you want to check it out. Jerry Berger wonders if they're using Chinese parts. Chances are yes, I would think. Oh, by the way, I'm wearing my SpaceX hat, not because this mission has anything to do with SpaceX, but because my hair is a royal mess, and I didn't have time to deal with it. So on the hat goes. What I need to do, I've been working to design a raw space cap. The thing is, it's going to be embroidered, so I need to come up with an embroidery compatible design. And they have very specific, like very tight requirements as far as the colors you can use and the distances between the different colors. It needs to be embroiderable. So I've been working on that. But once it's available, it'll be up in the Raw Space merch store, which is also linked in the video description. All right. Mark Desire says the Long March 5 rocket can be compared to the U.S. Delta IV Heavy. A bit less strong, I think. So, Long March 5 thrust. Let's see. I'm going to have to do math here, because we've got the core plus 4 boosters. So boosters for total thrust. Oh, that's total thrust. I see. Okay, so we got 2.2 million. And first stage is 230,000 pounds. Is 2,430,000 pounds of thrust at liftoff versus Delta IV Heavy, which has Yeah. 1.4 million times 3. So Long March 5 is 2.4 million total, and 1.4 times 3 is 4.2 million total. So about almost twice as much thrust on the Delta IV Heavy. Carton Yao asks, do I think there's extraterrestrial life? I mean, statistically speaking, given the vastness of the universe, it seems likely that there should be something out there. However, we have thus far detected none of it that we know of. So the universe, I mean, all things considered, if you gauge the average lifetime of a star, the universe actually isn't that old. I mean, compared to a human, it's incredibly old, but compared to, the life cycle, the stellar life cycle, there have only been, depending on the type of star you're talking about, there have only been a few generations of stars since the beginning of the universe, and therefore maybe we're early adopters. Maybe humanity, maybe Homo sapiens are the lucky ones that got into this young universe early. And turn this buzzer off. Maybe 10 billion years from now there will be many more civilizations out there, but we could be the first. Or maybe, maybe what's out there is not yet reached the information age, or maybe their signals haven't reached us yet because they're too far away. We have a sample size of 1 as far as life in the universe. So we really, all we can do is speculate and look for, listen for signals and look for signs of chemistry in the atmospheres of exoplanets that suggest that there may be life there. We do that using spectroscopy. It's a very cool science that I know very little about, but I know that it's extremely clever, an extremely clever way to, it blows my mind that you can analyze the light spectrum coming from a distant star as the light passes through the atmosphere of a transiting exoplanet, and by looking at the spectrum of that light, you can determine the molecules in the atmosphere of that planet. That just blows my mind. That's so cool. We can't see the planet, but we know what chemicals are in the atmosphere. That's just amazing. Due to land on the moon. Let me see if there's any. Okay, mission profile. It says the launch of Chang'e 5 from Wenchang is expected on November 24th. That's today for China. And it's early in the morning for them. Like pre-dawn. Sunrise over Mons Rumker will occur November 27, ahead of the landing. So that's sunrise on the moon at the landing site in 3 days' time, ahead of the landing. So it took the Apollo astronauts 4 days to get to the moon. It took Bereshit, if you remember the Israeli lander, they took a slow route, like a month or something, to get to the moon because they were conserving fuel, but that was a very different mission. And I think the Chinese will take a much more direct route. And they're using a big rocket for it, so they'll have plenty of delta V, plenty of thrust to get them there in a reasonable amount of time. So I think in about 4 days, 4 or 5 days, we should have a landing. And the mission seeks to collect 2 kilograms of rock samples by both drilling to a depth of up to 2 meters and scooping up surface material, which is going to be that fine powder and pebbles. Chang'e 4, the rover on the far side of the moon, was equipped with an RTG power generation device, which is a radioisotope thermoelectric generator. Basically, they use radioactive decay to generate heat, and it also powers the device, but also, in addition to that, it also keeps it warm. Chang'e 5 does not have that. It has no self-heating capability. Therefore, Chang'e 5 landing and sampling needs to take place within a single 14 Earth day, lunar daytime. So they plan on landing right after sunrise on the moon, and they need to launch before sunset on the moon. Because once once the landing site passes into the moon's shadow, onto the night side of the moon, the temperature will plummet, and the spacecraft is not designed for that extended period of cold. Total mission is expected to last 23 days. The landing will take place in Dorbad Banner, in Inner Mongolia, which is in northwestern China, next to Mongolia. Inner Mongolia is part of China, but it's next to Mongolia, around December 16th to 17th. So landing is going to be mid-December. Then samples transferred to a facility, specially developed facility, for handling such lunar material. And I don't think I mentioned earlier, this is an important point. This will be the first lunar sample return mission undertaken since 1976. There was a Russian mission, Luna 24, I think it was. So, yeah, very cool. China is now going to have some lunar samples to work with. Of course, by our, I mean the USA's Apollo program gathered a few hundred pounds of moon rocks, which was a bonanza. But off the top of my head, I don't know how much the Russian mission collected. But yeah, so let's see. Okay, all right. Looking back at the chat, see if there are more questions. Sinue Jimenez asks, and I'm way behind the times, I'm sorry for that, because I'm long-winded. Will the moon samples introduce any kind of virus to Earth? No. No. I mean, the material on the moon is irradiated like crazy because the sun is constantly beating on it with no atmosphere. But that's just solar radiation and cosmic rays. It's not, there's no... Now, I mean, presumably they will take precautions. I mean, when the astronauts returned from the Apollo missions, they, were quarantined for, what was it, 2 weeks, just in case, something, they were exposed to something, because we didn't know. But, no, the moon is quite dead. There's nothing alive there. Now there could be, I mean, there's ice there. There are pockets of ice in the shadows of craters that are permanently hidden from the sun, so they don't get baked. But yeah. So Jeffrey Walsh, American astronauts say they saw alien beings on the ridge watching them. No, they did not. Or if they did, they were kidding. If you can produce a primary source for that, that would be amusing. Moon is approximately 250,000 miles away. That varies by about 10%, because all orbits are, after all, elliptical. They're not perfectly circular. Even the Earth's orbit around the sun is elliptical. We're sometimes a little bit closer, sometimes a little bit farther away. And the moon's orbit varies by about 10%. So, and a supermoon, you may have heard of that, is when the moon is at its close point in its orbit at the time of a full moon. So it's both full and bigger, apparently bigger in our sky because it's closer. But it's not like super huge because it only varies by 10%. Ian Pedlar asks, what type of cheese are they after? Cheddar? No, it's the moon. It's Swiss cheese. Everybody knows that. All right. Alonzo514 says, how about the dark side of the moon? I prefer to call it the far side of the moon because it is on the far side away from us. The dark side is misleading because it suggests that on the other side of the moon that we can't see, it's dark, and it's no more dark than the near side of the moon. No, this craft will be landing on the near side of the moon. Now, the next mission, Chang'e 6, will be landing near the lunar south pole. And I think it may also be a sample return mission. I'd have to look it up, but I won't do that now because this is Chang'e 5. Chris A. What use of moon stuff will bring, given that samples have already been taken many years ago? Well, it's a different location, first of all, and China doesn't have their own samples of moon rocks. America does, Russia does, China does not. So they're collecting their own samples. That's pretty much that. Also, even though the U.S. preserves, like we take very careful steps to preserve our moon rocks in a nitrogen atmosphere in a vault, you know, in some NASA facility somewhere, you know, collecting fresh, hot off the press moon rocks is also useful in this, you know, I mean, we've got such, like, our analysis capabilities are far and away more advanced than they were in 1969 through 72. Brian Arnold, is Long March 5 the biggest Chinese lift vehicle? I believe it is. I believe it is currently. They may be working on a bigger one, but I think it's currently the biggest. I see people discussing the rotation of the moon. The moon is tidally locked to the Earth, which is pretty normal for a small body orbiting a larger body, although comparatively the moon is fairly large in relation to the Earth. But yeah, the moon is tidally locked, meaning roughly the same side is always facing us. You know, it wobbles a little bit. If you can see a time lapse of the moon, it does wobble a little bit, but yes, basically the same side is always facing us because its rotation rate has been altered gradually over the eons, such that the gravitational pull of, well, tidal locking is a fairly complex issue of orbital mechanics, and I'm not really prepared to dig too deeply into that, but over time it is normal for a small body to become tidally locked with its gravitational parent, so that it always faces the same side. Like, for example, Mercury, I believe, is Mercury tidally locked? Is Mercury tidally locked? I thought it was. Yes, it is. Well, it's tidally locked in a 3-to-2 spin orbit resonance. So, there you go. MVM Motovlog Music. With all due respect, I think there may be microbes living in the water on the moon. That's possible. Well, the ice on the moon. It's possible. There couldn't be water on the moon because liquid water evaporates in a vacuum. It can't exist in a vacuum. It evaporates, and then as it cools, freezes into microcrystals. But so there can be ice deposits. There cannot be water. Liquid water. Obviously, ice is water. All right. Nicholas, do you think that Blue Origin has a chance to be a rival for SpaceX? Maybe. I mean, their motto is Gradatum Ferociter, which means step by step ferociously. And I mean, they have been aggressively building production facilities for their up-and-coming BE-4 engine, which will be on both the New Glenn rocket, their monster New Glenn rocket, which is yet to be developed, as well as the Vulcan rocket from ULA. They'll also be using Blue Origin engines. But I am not sure what the status of BE-4 development is, nor New Glenn. Blue Origin is not very upfront with their, development progress. They're not as vocal as SpaceX, and like I even spoke with a Blue Origin employee one time, and he had no idea when the next New Shepard launch was, which is their little suborbital self-landing rocket. So, yes, there won't be any moon walks. There will be moon rocks. There will not be any moon walks because there are no humans headed to the moon at this time. For that, we'll have to wait for Artemis or maybe the Chinese if they get there first. We'll see. James the Voice asks, is the first stage based on the Energia heavy lift? I'm not sure of the history of the Long March 5 development. It's quite possible because a lot of the Chinese designs were, either copied or modified or inspired by Russian designs. Those being the two great communist nations of the world. MVM Motovlog Music asks, do I know if we will get video from the moon? Unlikely. I mean, for a human mission, absolutely. But for a robotic mission or just a lander mission, that's not likely. I mean, stuff up there doesn't change very much. And, like, the Earth is never going to move in the sky, and the moon takes 28 days to rotate. So even the stars aren't going to move very fast across the sky, the lunar sky. So, yeah, it's very unlikely that until humans put boots on the ground again on the moon that we will get video. Just images and time lapses. Joshua Sun asks, any update on the Artemis program? Does NASA have sufficient funding for this program? I don't have the latest on Artemis. I know that things are things are a little, I don't know if I would classify them as being up in the air right now, but there are questions as to how things will move forward. NASA Administrator Jim Bridenstine will be stepping down in January when the new president takes office, and he made it clear that he would be stepping down regardless of who won the election, even though it was the current president that nominated him for that position. But and he's a Republican senator or representative from Oklahoma, one of the reddest states. However, he will be leaving NASA, so NASA will be undergoing a change in leadership next year. And additionally, the new administration may have different priorities in their space policy as the current administration, and that remains to be seen. I don't personally have any knowledge of what Biden thinks about space, even though he has a long history in the Senate and is a vice president in American politics. I'm not personally familiar with that. I really abhor politics in general, so I don't spend my time looking that stuff up. Aerodynamic One says he doesn't understand why they talk about SpaceX and Blue Origin on a Chinese space mission stream. That's because, I mean, SpaceX is a squeaky wheel. I mean, they're the sort of the elephant in the room of spaceflight because they have become such a prominent figure. And I mean, the majority of the world's launches are now from SpaceX. And Blue Origin is an up-and-comer that is also high-profile because it's owned by the richest man in the world, Jeff Bezos, with infinitely deep pockets. He can afford to throw money at the problem of space to his heart's content. Devout Skeptic says, some people still deny the moon landings. I wonder why. Well, for one thing, they weren't there when the missions launched. I mean, if you were there and you saw the rocket take off, you definitely would not be a denier. Secondly, they, for whatever reason, have fallen prey to the modern, it's not a modern pattern of thought, but I mean, it's been around forever, but they've fallen prey to the trap of following emotions and personalities rather than empirical evidence and the scientific method. Because if you follow the evidence, we went to the moon. All of the evidence points to it. But, if you want to deny all the evidence and, pretend that we didn't go, then you're free to do that, but you're not going to be right. Yeah, let's not have any flat Earth trolls in here, please. We will kick you because it's disruptive to the chat, and ain't nobody got time for that right now. Boogie Hoogie asks, is China taking mass off the moon to prevent high tides? I'm afraid they would have to take a lot more than 2 kilograms, like maybe 2 billion kilograms or more. But Clarence Davis, thank you, very informative. You're quite welcome. I certainly don't have all the answers, but I have some, and I do what I can. And I can look stuff up too. Look stuff up all the time. Never stop being curious. Like, I don't at all mind looking things up, because anybody who thinks they have all the answers is almost surely grossly mistaken. Well, they are grossly mistaken because nobody has all the answers. Genghis Khan says seeing a rocket take off doesn't mean they went. Well, but it does mean, what it does mean is that according to the calculations of physics and rocket chemistry, etc., a rocket with sufficient dimensions and thrust and capacity and power have taken off and on an orbital trajectory, and there was coverage of the mission, from beginning to end through radio contact, telemetry, and live television transmissions. So, yeah, the only way to deny the Apollo landings or the sphericity of the Earth or anything like that is to narrow your vision so that you only see a fuzzy data point that you can then misrepresent and extrapolate into a cloud of doubt. Whereas if you actually correctly interpret the evidence and look at all of it, there is no question at all. Excuse me, there's no question at all. I'm not sure how well I said that, but I tried. All right. Alonzo 514, is it weird we do not have any satellites around the moon? We have had a number of satellites orbiting the moon. Now, orbiting the moon is tricky because it has an uneven gravitational field, and so... Oh, very cool. My timer is only, 5 seconds off? Here, let me correct that. Beautiful. All right. Good job, Snow Kittens. Thank you for that very accurate launch time. All right. What's orbiting the moon? Well, I don't want to go down that rabbit hole right now. Anyway, we've had numerous probes. Multiple countries have had probes orbiting the moon. I don't know if there are any currently right now, but I do know that orbiting the moon is tricky business. A moment. Because of the uneven gravitational field. Right. Van Allen belts, not so dangerous. You just... radiation is a matter of mitigation. You take measures to shield yourself, to travel through it quickly, to travel through the thinner regions of the Van Allen belts, and you'll be just fine. The Lear's Farmish. Orbiting the moon is tricky business, really, so my Volvo won't do it. Your Volvo could orbit the moon, but it would need to be placed in a stable orbit, or else it would degrade over time due to the gravitational perturbations and crash, which is what happens with most moon orbiters, is they crash after a while. MVM Motovlog Music, yeah, that's the, well, this is not necessarily the most coverage ever from China. That we for the there was a launch last year that had like 6 different streaming cam views. It was pure chaos, but yeah, always good to have coverage of a Chinese launch because we don't usually get to see them. Maybe that, well, not only is this a very high-profile mission, but also it's in a very public place. It's on Hainan Island, which is, you know, full of population and resorts and whatever. And there will be lots of civilians watching the launch, inevitably, whereas most Chinese launch facilities are, you know, very isolated, you know, maybe with villages nearby, but not much else. Certainly no population centers. Fairy Socks, can you show a Coke can next to it so we can get an idea how big it is? I don't have a Coke can. I could put a banana next to it. But to get an idea, it is approximately the height of an 18-story building, if that gives you an idea. And for perspective, the Falcon 9 is the height of a 23-story building. So the Long March 5 is about 50 feet, almost 50 feet shorter than the Falcon 9, but fatter. It's a fatter rocket. Yang Zhang asks, how does the Chinese lander compare to Curiosity? Curiosity being the Mars rover that landed a few years ago. It is the Chinese Mars lander. Which lander do you mean? The moon lander or the Mars lander that is currently on its way toward the red planet? I don't actually know like the capabilities of the Chinese Mars rover, but I'd like to think that Curiosity is as well as Perseverance are pretty advanced. I mean, JPL is top notch, and nobody does Mars quite like the Jet Propulsion Laboratory. But I couldn't say for sure because I'm not intimately familiar with the Chinese lander. As far as this lander, won't have a roving capability. I don't think it will. I'm not seeing any kind of roving wheels or anything on this. I don't think this is not a rover. It's just a lander. So it won't be mobile. All right, so I have gone over my time. I'm going to go ahead and switch to the live broadcast. I would encourage you all to enjoy yourselves, stay civil, be kind to each other, don't troll, and enjoy the hopefully successful launch of this first Chinese lunar sample return mission. Keep it raw, and I'll see you next time.
期间其实好多大系统都是要进行密切的配合。
对，
这个任务周期它延长之后，那么会使整个的这个工程的这个工程这个时间成本也会增加不少。
对，
所以说对一些复杂的这些任务，像后续如果执行载人登月的任务，那么直接从这个月球发射一个直接进入这个月球轨道，那么这样是大家首选的，特别是像美国那个阿波罗，它都是直接采用这个发射这个载人船直接进入这个月球轨道。
我们看到距离点火的时间越近啊，现在应该是长5火箭有很多的技术动作。
对，它现在这个小视窗已经切换到了好几个地方，
对，
大家关注的
不同的视角。
对，它这个切换的这个地方一般都是啊，刚才有连接器脱落了，对，
哇，
这应该是
连续有脱落哈。
对，我们应该是我们的这个氧的这个加泄连接器脱落，表明现在的这个舰上的氧已经加注好了，那个矿气已经增压好了，就储氧增压好了，这样的话就等着后面发动机点火了。
到目前为止看到，您觉得所有的技术动作应该都是
所有的动作都是按照我们预定的流程来进行的。应该说这个过程呢，应该是非常干脆和利落的。
明白。
后面我们要看到的就是这个摆杆摆开之后呢，就是所有的这个舰地的这些在舰体侧壁的这个连接，那就都已经都打开了，就是最后剩几个连接器都在火箭的底部了，就是。
各号注意，2分钟准备。
2分钟准备啊！我觉得我们越到这个点火临近的时候，我们好像越来越激动哈，
越来越激动，
声音不由自主都会
摆杆摆开。
对，我们期盼着这个火箭这个按时点火。
但是我们刚刚听到啊，指挥员的这个声音是一如既往的沉稳有力啊。
对，现在摆开，这个摆杆摆开的这个过程也非常漂亮啊。这个况且里面有这个低温的连接器，刚刚脱落下来，你看还这个冒着这个白烟的都。
对。那现在就是。
现在唯一看到的一个是那个和火箭连的是一个轻的一个紧急排气的一个
紧急排气。
如果说火箭点火过程当中出现问题，不能正常起飞，那么这个连接器它其实是不脱落的。不脱落的话，这样的话就是氢箱如果蒸发的话，可以通过这个连接器把这个氢气排走，这样的话就不至于对这个舰体周围排氢气造成安全隐患。
1分钟准备。
1分钟准备了。我刚刚看到长5的这个特写画面啊，也是能够近距离看到长5这型火箭非常漂亮，
非常漂亮。因为这个火箭整个的它的这个整流罩的气动外形和我们这个助推器的这个外形，
我们刚刚听到50秒，我们现在把时间完全交给现场。
40秒，
好
，40秒。
我们来聆听指挥员的每一次口令。
30秒，30秒。20秒，明白。10秒，9、8、7、6、5、4、3、2、1，点火。
大家看到发射台的喷水。这样的话喷出来大量的水之后，其实对发射台是一个保护的作用，因为火箭的这个尾焰的温度非常高，如果不保护的话，
起飞时间动4时3度分2幺秒，8度6毫秒。
这个火箭这个起飞过程非常
对。
因为是在夜间发射，所以这个地面光学看的效果就跟上一发可能相比就不如上一发好。
跟踪正常。
但是非常耀眼。
对，我们能看到这个发动机喷出来的这个尾焰，这个。
文昌光学雷达跟踪正常，遥测信号正常，文昌飞行正常。
对，现在一系列的正常的指令声发出来。
对，大家在这个这应该是穿越云层了，
云层了。
大家在这个观看过程当中呢，就是可以注意到这个火箭的这个尾部的这个火焰，因为这个尾部的火焰，这个从喷管喷出来之后，它是受周围大气的影响。刚才大家看到的这个火焰应该是比较亮，这个它的范围比较小。等随着这个火箭飞行，它这个大气压力逐渐降低，那么这个尾焰它会逐渐的膨胀，膨胀到后面它会把这个助推器的尾段
阵地遥测信号正常。
阵地遥测信号正常啊。
对。
每听到一个口令正常，我们心里就踏实。
对，大家看到的这个现在的 应该今天可能是也可能有一部分云，可能那个地面的光学可能相对来说看的不是特别清楚。现在咱们看到的这个是从这个舰上的这个一级舱，我们有一个外挂的一个摄像头。那么这个摄像头呢，就是通过这个舰体外部，然后从上往下看，大家相当于是站在火箭的一级舱往下看，看到的这个应该是2个助推器，好和这个尾部的这个火焰的形状。
刚刚是已经顺利点火，我们现在在关注着。
现在这个时间段主要是火箭克服这个重力，就是尽快的这个把高度提上来，把高度打够。现在看到这个尾焰的这个形状已经。现在已经这个画面已经切到了这个
文昌雷达跟踪正
发动机舱
常，
里了。
遥测信号正常，文昌飞行正常。
这个摄像头，因为这个长五火箭带了15个摄像头，也就是有15双眼睛，帮我们在这个飞行过程当中监测这个火箭的这些状态。对，刚才咱们看到的这个右面这相当于是右上角这是舰体外部，看到的这个应该是现在的这个随着飞行，它这个高度已经比较高了，你看出来的尾焰已经出来偏蓝色，偏那个它这个范围越来越大了，就是，左边这个是飞行过程当中的一个根据这个火箭的适时的高度和速度信息，来模拟出来的一个动画。
那我们非常关心的就是这个助推器，
马上就要分离了。对，助推器是火箭起飞170秒左右。助推器分离。分离的非常漂亮。
对，这个动作非常的
非常干脆利索。对，应该说这个助推器的这个分离是我们火箭
我们看到现场已经
非常重要的一个节点。
跟踪正常。
对，工作人员有掌声传来。
这个一个是表明我们这个全舰这个液氧煤油发动机和我们助推器工作是正常的。这个。完成了火箭的这个从这个海平面的高度提升到我们这个助推器分离，大概已经到了这个70公里左右的这个高度。
7杀424跟踪正常。
接下来的一个动作，大家可能看到的话是整流罩分离。
整流罩分离啊。
对，我们的助推器，
我们的嫦娥5号
嫦娥5号要露出真容来了就。因为
时间现在已经过去了快230秒的时间。
对，我们整流罩应该预计300秒左右这个分离。
文昌雷达跟踪正常，遥测信号正常。
我们的助推器它的这个分离完之后，它的落区是在我们国家的这个是在我们的南海海域。应该说是这个它的落区还是非常好的。这个基本上没有什么那个人员和岛屿。这个也是选择文昌发射场的一个优点。
发射场的一个
落区比较好。
对。
而这一次飞行，因为整个的是向一个东南方向飞行。这个飞行的路径是跨过菲律宾，所以说这个整个的这个整流罩的这个抛照时间呢，我们也进行了一个优化。本来整流罩我们这个抛照呢，只要整流罩到达这个真空之后，到达100公里以上之后，整流罩就可以抛掉了。但是考虑到这一次呢，就是它的这个飞行路径下面是要跨过菲律宾，所以我们这个把这个整流罩的这个时间呢，相对来说延长了一点。这样的话，能使这个整流罩抛照之后呢，它的这个落区这个控制在这个菲律宾的东面。
我们现在看到的画面是整流罩里面的
整个罩带的一个摄像头，它这个摄像头的功能呢非常重要，一个是监测这个整流罩分离，另外一个呢就是这个
抛整流罩，
最后这个火箭和抛得非常非常干脆。
漂亮，
况且大家也可以能看到，整个因为它是一个薄壳式的结构，它在分离过程当中，它还有一定的相对来说这个弹性的这个晃动作用。
对，
大家仔细观看可以看到这个现象。现在的应该是我们的这个有效载荷已经那个什么了，露出真容来了。
刚刚这个整流罩非常干脆的分离以后，我相信这会儿前方的这个指挥大厅应该又是有掌声传来哈。
对，从那个现场的这个大家基本上这些关键的分离动作，和发动机的一些点火关机动作，那么都是这个火箭飞行过程大家关注的点。这些点执行的干净和漂亮之后，现场的这个气氛就是一次比一次热烈的。
下一个我们要等待的一个关键的环节，应该就是发动机的一个分离了，是吧？
对，现在的这个应该是我们的这个1级发动机它的工作段。这个1级发动机用的是这个氢氧的这个推进剂。因为它的这个推进剂呢就是性能比较高。另外一个呢就是1级的储箱非常长。我们可以看到现在的这个储箱的这个长度，实际上大部分是1级的这个长度，1级长度，而且1级的这个飞行时间是480秒，这个时间呢也比现在的我们国家这个一些其他型号的火箭的飞行时间明显的要长。它的一个主要的这个特点就是通过这个1级的这个工作时间延长呢，使我们火箭的级数变少了。像我们前面几次任务发射嫦娥任务，都是用的长征3号系列的这个火箭，长3甲、长3C 和长3B。那么它是一个3级班的火箭。而到长5这边，这个整个的这个探测器重量大了，但是呢，火箭的级数反而少了。
它变成一个现在变成
是个2级班的一个火箭了。
对，
这个主要的一个原因就是因为这个火箭的1级，它的用的是氢氧的推进剂，它的这个工作时间是相对来说是2级的工作时间。这样的话，对这个火箭来说，相对来说它这个1级工作完之后呢，我们达到这个高度和速度应该是比较高的。
文昌雷达跟踪正常，遥测信号正常，文昌飞行正常。
伴随着这些指令哈，我们现在双视窗里面也能够看到前
方那个我的一些战友、
指挥大厅啊，
对，他们这会儿都在目不转睛的这个关注着火箭的飞行的一些关键参数。
对，
其实我们在飞行过程当中，更多的关注火箭的高度和速度信息。
高度和速度。
对，这2个如果说高度和速度，如果说是跟我们理论曲线吻合的好的话，就表明火箭飞行还是宏观的参数都是正常的。如果说一旦出现这个高度和速度出现偏差之后，那么代表火箭的这个不管是推力还是它的这个姿态已经出现了比较大的一个偏差了，就是。
现在我们在动画的下方是不是能够看到
1级关机？
好像是我们整流罩的一个落区的一个大概的演示是。1、2级分离了。
1、2级分离了，那就1级。那么现在看到的是2级的75D 的发动机的点火。
对，我们刚刚是不是应该也有听到现场这个指挥大厅的掌声是吧？
对。对于长5这型火箭来说，那么1、2级分离也是非常关键的一个动作和一个关键技术。因为我们这个2级的这个储箱呢，就是特别是氧箱，它采用了3:35的一个结构。那么在咱们刚才看到的这个火箭整体画面，实际上是看不到那个氧箱的，它被我们的机尖段那个包围起来了。这个机尖段呢有8米长，也就相当于是我火箭分离过程当中，要这8米长的这个机尖段要从2级的这个氧箱和发动机要把它拔出来。
对，
这样的话是在真空中分离，还是风险还是很大的。前期我们做了大量的这个仿真工作，确保各种极限偏差情况下，这个分离是安全的。
我们现在看到画面上哈，最下面是火箭的一个位置变化，对吧？还有它的高度变化，
对，
速度的情况啊，然后整个的下方，我们刚刚看到还有远望6号船也是在对它进行观测。
对，现在的话是切换到这个整流罩里面的这个图像信息了，就是看到的是有效载荷的这个状况，
就是我们嫦娥5号的状态。
应该说我们现在的这个火箭应该是，向着这个东偏南的方向飞。所以说我们这个，因为我们的摄像头是装在这个，装在我们的这个有效载荷支架里面，和这个嫦娥5离得很近。看到的话是看到这个，嫦娥5号最近的这个真身面容。
对。
刚才看到了，就是在我们的视场内是向着这个看到了太阳。应该是我们这个正好就是飞行到那个相关的高度。应该是正好能看到这个所谓的日出嘛，也就是
对，
正好这个点对应的这个太阳的这个能在我们的这个视野里面。看到的这个右上角的这个呢，应该是我们这个2级发动机舱里面的。
对。
发动机舱里看到的是2台75D 发动机它的工作情况。因为75D 发动机属于高空的这个氢氧发动机，它的推力呢，那个单台发动机推力大概9吨多左右。所以说在真空下看它这个燃烧呢，基本上不是特别不像地面的发动机，火焰那么大那么亮。所以看到之后，如果不仔细看的话，你只能看到喷口局部的地方是发红发亮的，其他地方像尾焰不是特别明显。这是又切换到这个 个
整流罩的画面，
整流罩的这个画面了，就是。
你看，现在距离点火应该是过去10分钟左右的时间了，
大概飞行600多秒了
，600多秒了，对。那可能很多的观众也在好奇，我们现在一路还在非常密切地关注着火箭的最新的动态。那到哪些技术状态的时候，我们才能够说它的飞行是现在是一切顺利的呢？
现在来看，就是通过现场传回来的这个画面和这个高度和速度信息来看，现在火箭的这个飞行状况还是非常良好的，
比较良好啊，非常良好。
那个另外一个呢，就是看到这个755D 发动机，它的工作也比较平稳。它的工作过程当中，其实发动机在工作过程当中，它的这个一般出问题的概率还是相对来说低一些。发动机就是特别是高空发动机，它容易出问题的环节在它的这个启动段。
启动段。
对，启动段是高空发动机，它的因为我们这个发动机是在真空下点火，它的这个主要的技术风险和难点是在点火段。
就是一会儿发动机会，尤其是它这个2级会进行一次关机，然后再进行一次重启，
再进行一次重启。
对，
这是这个对于任何一个国家来说，搞低温火箭，低温发动机的这个真空启动和2次启动都是一个技术难点和一个比较难攻克的一个难题。
我们现在看到飞行时间已经过去了740秒的时间。
2级依次关机。
2级依次关机了。
2级依次关机，表明现在的这个火箭和飞行器其实已经处于一个
又有掌声传来啊！
对，其实
依次关机也是很顺利。
很顺利。其实这时候已经处于一个一个近地圆轨道的这么一个大概的这么一个轨道范围。那么这时候火箭的高度呢，基本上快到了这个180公里以上了，这是那个速度呢也比较高了。关机之后呢，就是大家可能这次滑行呢，因为我们采用的是第一条弹道，准时点火嘛，就是分秒不差，所以说是第一条弹道。这样的话，它的滑行时间呢，就是将近达到了1000秒，这个滑行时间还是比较长的。
对，
在这个滑行期间内，大家可能看到的这个舰上的画面已经不是特别就不是特别多了，就是
不是很有动态了，
不是很有动态了。
对，
但是呢，就是我们能看到它的这个位置和速度信息，特别是它的经纬度信息，它是实时在变化的。另外一个呢，就是火箭在这个大概1000秒左右的滑行期间内呢，实际上还不是一个简单的纯滑行状态。因为
什么呢？
我们的这个2级的也是用的氢氧的推进剂。氢氧的推进剂呢，就是如果是处于一个完全滑行状态，那么它就是一个零重力的失重状态。那么失重状态这时候呢，就是再次启动，对火箭来说，这时候启动难度会非常大。
它就不能完全依靠惯性，是吧？
对，不能完全靠惯性。所以我刚才说到，我们舰上有一套辅助动力系统，它那个射前有加温的功能。那么这时候它的就派上用场了。
就是此时我们看到的画面当中，这个辅助动力系统也在发挥着作用。
辅助动力系统它在发挥作用。它的作用呢，就是提供一个比较小的推力，持续的在推这个火箭。那么因为有一个小的推力，那么这样的话，火箭其实是有一个比较小的一个加速度。那么有这个小的加速度，那么就造成我里面的氢箱和氧箱里面的推进剂实际上是处于一个沉底状态。那么处于沉底状态的话，就是有几个好处。第一个好处就是在火箭第2次点火启动的时候，这个推进剂状态是个确定状态。另外一个呢，就是我们这个要保证这个火箭启动，实际上这个储箱是要进行气体增压的。那么增压的气体一般都是一些热的气体。那么推进剂比较冷，我这个滑行期间不能让这个冷的这个推进剂和这个热的气体掺混。那么掺混完了之后呢，就会造成这个储箱的压力会大幅下降。在这个过程当中呢，就是要给它一个小的一个推力，让这个火箭的这个气和液处于一个分离状态。那个让这个推进剂一直处在这个储箱的底部。实际上是有几个小的推力室在工作。那么这个小的推力室它用到的是我们的辅助动力系统的一些它的小推力室。
对，我们现在看到画面上已经火箭 在不停的顺利的飞行着啊，
对，
是有一些新的地标哈，目的地从这个下方出现了。
对，现在的这个其实设置这个滑行的这个目的呢，也就是因为火箭它这个通过一个滑行之后呢，我们可以使它关机的时候就是在我们指定的位置关机。如果说没有这个滑行的话，那么火箭这个点火之后一直工作，那么我们这个关机点应该是在这个是在北半球。那么在北半球，如果关机点的时候，火箭的速度达到了最大，也就是这时候是这整个奔月轨道的一个近地点。那么如果是在近地点的话，是在北半球的话，那么我们到这个月球之后呢，就是到南半球去了。现在我们月球处于北半球。
对。
所以说我们为了就是我们的远地点，在北半球，所以我们一定要把火箭的这个墨迹给它送到这个南半球去。在南半球关机，形成这个近地点，这样的话，它对应的这个远地点才能到这个北半球。这样也就是为什么这段时间要让火箭这个没有动力的这个滑行一段时间之后，到了指定的位置，我们再去点火，再去让它工作。实际上是为了获取火箭关机时候获得一个准确的一个位置和速度信息。
所以我们现在看到的这个静静的滑行段啊，其实是为了
实际上是为了我们最终这个最终那个器件分离的时候入轨点，
对，
满足我们的设计要求。这样是让它这个去滑行去。
我们看到啊，左边的双视窗啊，
刚才看到我们
前方的指挥员的画面，
前方的指挥员，对，我们实验队的队员，大家在交流讨论。
看他们的表情，好像感觉呢，我们能够感觉到，目前为止一切还是很顺利的，
比较轻松。
对，
这样的话，你看到的火箭的信息，刚才看到的是我们这个辅助动力系统的主任设计师。
Hey everybody, I figured I'd come back on and answer some questions vocally, since not too many of you here can understand the Chinese speech, I don't think, and there are some questions. Mudbog Mods is asking, didn't they do Chang'e 4 last year? Chang'e 4 was the rover that landed on the far side of the moon. Yeah, I think that was last year, and that was successful. Let's see, Dennis, how long will take the whole stream, please? So I have no idea how long CCTV is going to be broadcasting this coverage. We've had separation, and if we look at the diagram there, that appeared based on the Chang'e 5 diagram we looked at on Wikipedia before the live broadcast. This looks like it may be the optional upper stage of the Long March 5, and then the orbiter. So let me take a look. Maybe I can switch here. Let me switch real quick to the other view. So we've got the orbiter with its little solar panels, and the lander on top of it, and then the descender on top of that, with the reentry module, reentry capsule squished in between. And so here, yeah, there appears to be an extra piece there. I think that may be the fourth stage, or the upper stage. The Lears Farmish asks, will this be like old Saturn, where they make an orbit and then slingshot off to the moon? So that is to say, will it orbit the Earth and then execute a translunar injection maneuver? That's quite possible. And this extra piece on the bottom there with the two engines that we're seeing in the graphic is quite possibly going to execute that maneuver, the translunar injection maneuver. Here we go. So here's an old drawing of the Apollo translunar injection. So They launched, they orbited the Earth, and then on the left side there you see there was a translunar injection which boosted the vehicle out of Earth orbit and into a trajectory that took it to the moon, where it then swung around the moon. And the trajectory for the different Apollo missions varied. I mean, like, but yes, the basic idea is you're orbiting the Earth, you execute a translunar injection, it takes you to the moon, the moon's gravity swings you around, and if you're continuing to orbit the moon like this orbiter stage will do, waiting for the lander to get its work done, then it will execute a burn to stabilize its orbit around the moon. The lander will descend, land, do its thing. The ascent stage will pop up and rendezvous with the orbiter, which will then execute a burn to bring it back to Earth. Ian Pedlar, do I think it was the real Elon who said hello earlier? No. Elon doesn't watch my YouTube channel, I'm pretty sure. Although if he does, if he could give a shout out, that would be great. Because that's like instant 20,000 extra subs. Hugh Salter, no problem. Glad to be of service. He just thanked me for commentating in English. George Cosma thanks me and says the Chinese space program tends to be ignored most of the time. Yeah, I mean, they don't make it easy because they don't broadcast very many launches. Most of them are hush-hush, or, I mean, a lot of times we don't even know what the payloads are or what orbits they're headed to, or much of anything, what the missions are. But they are a prolific launcher of satellites, and usually it's either they or SpaceX that have the most in a given year, depending on launch schedules. This year is weird because of COVID, but the Chinese space program is easy to overlook, but they are not to be underestimated. They have a very robust space program that and decades of experience that are valuable for getting their missions done. Ice Vogel asks, does the ESA work together with China? I don't think so. I don't think I've ever been aware of an ESA-China collaboration. I mean, obviously the ESA works with NASA and with other space agencies. ESA has worked with ISRO, the Indian Space Agency. I'm sure that ESA has worked with JAXA, the Japanese Space Agency, even though I don't specifically recall on which mission. But I'm not aware of any other space agencies that collaborate with China. And if they collaborate with Russia, that would be not something that they would tell us about anyway. So I don't know. But they tend to operate sort of on their own for the most part. WPGG says he hopes moon travel will be a reality before he dies. Hopefully. I'd be very interested to know whether human beings suffer bone loss in low gravity environments such as the moon or on Mars. Now we know we suffer significant bone loss and bone density loss in zero gravity, but we don't yet have a baseline. We don't have any data on potential bone loss in lower gravity environments. Because if we do, because of course our bodies evolved for 9.8 meters per second squared of gravitational pull on the surface of the Earth, and so the density of our bones is optimized for that gravitational pull. So, if our bodies deteriorate, if our bones deteriorate in lower gravity environments, then that could be very disruptive to establishing permanent bases on either the moon or Mars, because the residents' bones would become brittle, they would become weaker. And I don't have, I know that the astronauts on the space station, they, excuse me, all this talking. The astronauts on the space station engage in resistive exercises for 2 hours every day in order to fight the effects of bone loss and bone density loss. And I'm not privy to the data on that. I'm not sure what they're, because we've had continuous presence on the space, continuous human presence on the space station for 20 years now. This year is the 20th anniversary, which we just passed a couple weeks ago. The longest stays on the space station were over a year. If you remember, what was it? Scott Kelly, Mark Kelly, I forget which one. But yeah, so I'm not sure what the data is on the mitigation of bone loss by resistive exercise. That's exercising basically with rubber bands attached to you, pulling you down onto a treadmill. You're still in zero gravity. Your bones are still subject to no gravity, but they're being pulled down onto the treadmill surface by these bungee cords. Lock Talk Sports, this broadcast is entirely real, and we're watching currently an animation. Obviously there is not a chaser rocket that's zooming up alongside the Chang'e 5 mission capturing video for us. This is a telemetry driven animation representing where the spacecraft is at this time, and we see the thrusters firing there. Synaptic, thank you for the whole stream of commentary. You're quite welcome. By the way, I forgot to mention, oh yes, welcome back, Tig Rayhoff. I don't know what, welcome back is returning member and Rostronaut Tig Rayhoff. I don't know what happened to your membership, but yeah, so he was a member and then I guess it dropped him or something. It's not anything I could have done. It was either YouTube or a glitch or something. Sarah Jekyll and others. Yep, it's my pleasure. I love to bring launches from around the world to you so that you can view them and in a single place instead of having to search high and low. Especially these Chinese launches can be tough to track down. And I have to give extra props to our channel regular and friend Snow Kittens for providing the source feed for this, because I'm pretty busy with full-time work and everything, and I don't always have the opportunity to track down the Chinese feeds because they're not obvious. Peter S. is asking if this is the translunar injection burn now. I'm not seeing any telemetry, so I can't, we can sort of eyeball. Does it look further from the Earth than it was a few minutes ago, presumably? Troidy69, what is the speed now? We don't currently have access to the telemetry, so I'm not sure on that one. Chris Bittner, how long is the burn to leave Earth's orbit? So, according to Wikipedia, the optional third stage, the YZ2 on the Long March 5 rocket has a burn time of 1105 seconds. Now that's the burn time on the that the engine is rated for. I don't know if that's specifically the burn time for this mission, but those are the numbers from Wikipedia. Lock Talk Sports. If it says Flat Earth Wikipedia right under the video, that's because YouTube is kind of weird, has been exhibiting this weird behavior lately where it tags completely normal mainstream science videos, such as, like, I think it even tagged a NASA broadcast with the here's information about flat Earth, panel, which is like what it normally does for videos and broadcasts that are of questionable accuracy, like as part of a continuing effort to fight misinformation and disinformation, and the propagation of wildly inaccurate conspiracy theories such as flat Earth and other such nonsense, or Apollo moon hoaxers. YouTube places those panels underneath videos to try to give people some accurate information. I don't know why it's been doing it on regular non-conspiratorial science videos, but it has been doing that. So YouTube is weird. It's been doing a lot of strange stuff lately. WPGG, will you upload the rocket launch video later? Some of us want to watch the rocket launch again. Now, I mean, you can rewind this stream. You can just track back to, it's about, let me see, it's about negative 36.5 minutes to the launch as of now. But yes, I'm excuse me, I'm streaming this. And after the stream is done, the video will be watchable. And if there are any copyright issues or anything like that that require me to take down the video or edit it in any way, then I may have to re-upload it. But basically, yes, this stream will be viewable after it is done. MVM Motovlog Music commends China on all the visuals. Yes, they're quite nice. Much better than some of our launch providers like ULA, who their telemetry-driven visualizations are whoa, we're spinning, man. Look at that. How cool. And you know what? I'm going to switch back to the broadcast for... Oh, okay, they switched videos. Oh, look at that separation. So this is the third stage separating from the spacecraft, from the Chang'e 5 orbiter, lander, ascent module, and re-entry capsule. You see that single engine on the orbiter module. Duplicate. I'm sorry. I I have a tendency to respond when people say things, so that sometimes includes responding to trolls. Not intending to feed them, but I have a hard time simply ignoring them. Okay. All right, I'm going to go ahead and switch to the raw feed for a bit so that we can capture some of these views without my my mug in front of it. I suppose I could just take myself off the there we go. I can still talk.
秒级的这种精度，那么这一次呢，就是精确到秒级了。
文昌器件分离点参数，探测器出轨根数已发出。
所以到现在这个技术状态，是不是可以说火箭长征5号遥五火箭的任务基本完成了？
对，那么从刚才看到的这个器件分离完之后，那么对于火箭来说，它的这个主任务就已经完全做完了。它的这个主任务就是顺利的把这个探测器送入这个地月转移轨道。那么后面呢，其实火箭它还有一些相关的一些动作。那么它的动作呢，主要就是舰体的一些钝化和后处理。那么我们大家都知道，就是火箭飞完之后，其实它里面的这个一些气体和液体，大概率情况下是用不完的。用不完，这样的话，低温的一些推进剂和高压的气体，包括我们舰上的一些电源，实际上如果说不去处置的话，它长期在这个太空漂浮的话，容易产生一些太空的碎片和垃圾。那么这样的话，我们等这个和这个火箭和探测器拉开足够的距离，火箭是要对这个舰上的一些低温的推进剂，包括气体。
Okay, so one of the reasons why I sometimes respond to trolls is because even though the trolls may be way out of line and wildly off base in terms of their statements, it still provides an opportunity for clarification and maybe some education. So somebody, I think it was Lock Talk Sports, mentioned something about escape velocity from the Earth being 25,000 miles per hour. Let me just validate that here. Escape velocity from Earth. Oh gosh. Yeah, 25,000 miles per hour. That's measured as an instantaneous escape velocity from the Earth's center of mass. So that's a theoretical value. The actual escape velocity from the Earth, you know, at orbital altitude is much different. You know, a few thousand miles per hour, not 25,000 miles per hour. Now, I'm not a rocket scientist. I'm not a I haven't even played Kerbal yet, Kerbal Space Program, but yes, I do know enough to say that the escape velocity values you see are measured from the center of mass as an instantaneous escape velocity value. So nothing like it's a theoretical value. It's only of limited use for practical applications because you're never going to be taking off from the center of the Earth.
气垫分离之后下一个应该是要更新的技术状态哈。
更新的就是大家要关注这个探测器的这个太阳能帆板的打开。
对，同时我们接下来再来。
MVM Motovlog Music. The translunar injection appeared to be that final burn from that third stage of the Long March 5. And so currently what we're seeing is just the spacecraft. The Chang'e 5 orbit stage is the bottom fat part with the folded up solar panels. And the tapered bit to the top of it is the descent capsule, or rather the re-entry capsule that will come back to Earth with the sample inside. And then on top of that is the lander, kind of like our LEM. And on top of that is the ascent stage, which will ascend from the surface of the moon back up to the orbiting spacecraft. containing the lunar sample. 2 kilograms. Astromint, will the samples be available for others too, or just China? My suspicion would be just China, but I don't know for sure. I know that the American lunar sample, I mean, we have a lot of lunar samples, hundreds of pounds, but it's kept in a nitrogen gas, inert gas storage vault, and it gets cut up very carefully, cataloged. They keep detailed maps of what slivers of what rocks came off of which pieces, and they distribute it all around the world to researchers, institutions, and some of them some pieces of moon rock end up as like gifts to heads of state, or but most of them are just used for research purposes.
而且基本都是按照预定的时间。
对啊，应该说这个通过这个
完成，
通过这个飞行时间和它这个预估的时间和咱们这个实际的时间来看，应该说整个火箭上的各个系统的，特别是动力系统的，它的工作应该是非常非常好的。因为如果发动机工作过程当中出现一些偏差，包括它推力出现散差大的话，那么会使我们的这个飞行时间有一些延长，或者是这个一些出现大偏差情况下，那个会出现很大的一些不光是飞行时间延长，可能还有一些飞行高度和速度的一些偏差。
调整的那个
调整的过程占了很长的时间。那么从这一次来看的话，整个的它的这个发出的时序和我们理论的这个理论点的时序，这个时间吻合的很好，那就说明我们基本上舰上的各个系统，那么都处在我们设计参数的基本上在它的名义值附近，就是没有出现大的散差。
从整流照里面就能够看到哈，嫦娥5号的这个太阳帆板，
对，这个
器件分离，
这是火箭飞行的和有效载荷的之间的最后一个动作。
对，非常令人激动的。我们
So this here is a replay. That briefly was a replay of the separation of the spacecraft from the third stage of the Long March 5.
分离前一直能监测这个有效载荷的状态，分离过程当中和分离后还能目送它一程，让它那个踏上这一次不平凡的这个探月之旅。
So at our peak, we had I don't know, maybe 2,700 viewers or something like that. We're currently a little over 1,000, but we only have 500 and some likes. So if you find this stuff interesting, please go ahead and click the like button. I know all streamers say that, but the reason why it's important is because by you clicking the like button, you tell the almighty YouTube algorithm that you actually enjoy this content, and then YouTube knows to recommend it to more people who might find it interesting. So please go ahead and do that. And if you like rocket launches, make sure to subscribe, because I stream all of them that I can, which is almost all of them. Unless they're secret, like Russian military.
但是这次我们期待着任务，如果一切顺利的话，其实我们是他们这个。
Maria Kutujan asks, "What's the name of the craft that will collect the samples?" So the overall mission is called Chang'e 5, which I neglected to mention this before, but Chang'e is the name of the Chinese goddess of the moon, ancient legend or whatever, and Chang'e 5 is the fifth in their series of lunar exploration missions. So again, looking at this view, the bottom part is the orbiter. The tapered part is the re-entry capsule that will bring the sample back to Earth. On top of that is the lander, and on top of that is the ascent stage, which will blast up off of the lunar surface to return the sample, and rendezvous with the orbiter, which will be going around the moon. So the part that will collect the samples is on the lander, or perhaps on the ascent stage. I'm not sure if they're gonna reach over with a robotic arm or drop a piece down I'm not sure exactly what the mechanism is.
为国家做出这个科学探索做出它应有的贡献，这也就是我们火箭人在为什么每
Killer Basti 93 says, just out of curiosity, but is the similarity of the orbiter part of the probe on the bottom to a Soyuz, or the Chinese equivalent service module, just a coincidence? I mean, it may be. Like, I'm not privy to the Chinese. Well, I'm not privy to anyone's spacecraft design process, so all I could do is speculate, but it is very possible, in fact, probable, sorry, my throat's very rough, probable that elements of this mission were heavily inspired by Russian designs, because, again, China and Russia are sort of peas in a pod on that side of the world, so. I need some of that Gollum juice. Back when they were filming Lord of the Rings, and Andy Serkis, the actor who voiced Gollum and did the motion capture, had to use that Gollum voice all the time. His throat would get rough, and they came up with this special Gollum juice drink for him that had like honey and tea and a bunch of other stuff in it that he would drink to keep his voice from getting messed up. I'm just not used to talking so much, so fairly quiet guy most of the time.
那么，况且今年这几发任务特点就是每发任务又有每发任务的特点，都不一样。这一次是这个嫦娥5号的这个探测器执行我们国家的探月3期任务。
对。
上一发火箭呢，又是我们国家第一个的这个深空探测。
Chuck Vanderbilt asks, will there be another burn for lunar transfer, or is it now set and on its way? So what we witnessed a few minutes ago was the separation of the third Long March 5 stage from the spacecraft. And so what we see now on the screen is only the spacecraft, the orbit stage, and everything that will be going down and coming up from the moon. So it is on its way to the moon at this point. And in about... Oh, here we get an animation of how it's going to drill. So they have a little arm that comes out to collect some surface samples. There's the ascent stage, boosting off the surface of the moon. Now it's going to spend most of a full lunar day, so about 14 days, on the surface, at which point it will boost back up to rendezvous with the orbiter and then return to Earth. We see it here rendezvousing with the orbiter and presumably delivering its... There we go. We see the sample being transferred between the ascent stage and the re-entry capsule, because the ascent stage that comes up off the surface of the moon isn't going to be returning to Earth and isn't going to be landing. It's not able to do that. You need a capsule that is designed to take the heat of re-entry and ablate it and distribute it around the craft. And so that's why the sample needs to be transferred from the ascent stage to the re-entry capsule. Very nice. Ian Pedlar, no, this will not be a touch and go like OSIRIS-REx at Bennu. By the way, my cat is named Bennu. I haven't seen him this whole stream. He's been hiding from me. Otherwise, you might see him jumping up on my shoulders and stuff and getting in my way, which would be perfectly fine. Yeah, nor a bounce like with Hayabusa. Oh, there he was. Roland Thies, or if I pronounce that correctly. How are they preventing burnup on reentry? Well, that's why they, in that animation you saw a minute ago, that's why they transferred that canister, that cylinder, which contains the lunar samples. They transferred it from the ascent stage over to the reentry module, which is, in this view we see here, is the tapered part in the middle, the conical shaped part. And so the only part that will be returning to Earth in one piece will be the reentry module, and it's shaped just like any other, or the reentry capsule, and it's shaped just like any other capsule. The optimal shape for reentry is well established, and we've been using the same shape essentially for ever since the Apollo program. So the sample will be contained within that, and they mitigate the heat of reentry via usually a couple of methods. First of all, the shape of the capsule diverts the heat around the capsule so that the plasma sheath doesn't interact with any. Oh, there we have the solar array deployment. The plasma sheath doesn't interact with any sensitive parts. It only interacts with the ablative heat shield. Now, ablative, what that means is it's designed, the bottom of the capsule is designed to absorb the heat of reentry and to actually burn and absorb that heat. So it destroys itself, it sacrifices itself as a way to process the heat of reentry. So some of the heat is diverted around the craft, and some of the heat is absorbed into that ablative heat shield, as well as the angle of reentry is critically important. You have to re-enter at the correct angle, or you're not going to get optimal distribution of heat around the capsule. And yeah, so there you go. And I might have missed a point, but you get the idea.
按照计划呢，此次嫦娥5号任务将历时20多天。那接下来啊，我们再通过一段动画演示来了解一下嫦娥5号的任务流程。
Okay, can't allow any music, as we know there will be copyright claims. In fact, it's always possible there will be a copyright claim anyway, because people like to protect their content. But all right. Alonzo 514, what color cat? So this little guy here that I just put in the chat, it's a small picture, but that's actually my cat. So he's a tabby. He's colored like a tabby. And I got him right around the time that OSIRIS-REx was about to collect its sample from Bennu. In fact, I think that live stream was going on at the very moment that we adopted him. He was a rescue. He had been abandoned, left in the forest to fend for himself behind the pet store. And so we rescued him, and yep, he terrorizes me daily. And I have the scratches to prove it, which is just fine. Aldo Skies 8. Hi, are the lunar samples returning to Earth live? No, I don't think so. That sort of the sample return is not generally the sort of thing that would be that would be live broadcast, especially by China. There are other sample return missions on their way for Japan, and also for the sample from asteroid Bennu won't be returning for a couple of years yet, but yeah, when it does get here, there may be a live stream. there probably will be a live stream for that one. Usually the American missions get a lot of media coverage. But Ice Vogel, is this real or an animation? So these views we're looking at now are just simulations, computer simulations, renderings. But the launch was obviously real, and the view of the spacecraft that we were looking at was a simulation that was driven by telemetry. That is to say, it was showing us what was actually happening at the time, because, again, there's not a camera following the spacecraft to live stream. All right. So it looks like that is it for now. Thank you all for coming. Let me see if there are any more questions. 2025, what feed channel is currently on screen? This is, it's coming from CCTV, the China station. I had heard it would be broadcast on CCTV 13, but this is not, I don't think this is CCTV 13, so credit goes to CCTV, but I'm not sure exactly which channel it's on. It doesn't, well, if it does say on screen, I can't read it, because I don't know Chinese, but all right, so thank you, moderators, of course, for your tireless assistance. Thank you to the viewers for coming. Keep it raw, and hope to see you in the next video. Remember, we have a Starlink launch tonight, unless it gets delayed again. So stay tuned, and I will catch you later.